And yet another interesting discrete probability distribution is this one. It's called the geometric probability distribution. And it's related to the binomial distribution in this way. Imagine you have an experiment in which you repeat binomial trials until you get a first success, all right? That's the key here. You have these binomial trials. Now remember, binomial trial, there's two outcomes. Probability of success every time you do it is the same. So you either get a success or a failure. And what we're imagining here is an experiment where we repeat it until we get the first success. So we'll use our regular notation here. Let's suppose that P, small p, suppose that small p is the probability of success on a single trial, and then Q, 1 minus P, that'll be the probability of failure. So just suppose we want to get the first success on trial 4, right, just for example. If that's the case, what we're going to want then is this. 1, 2, 3, 4. What we want is a failure, a failure, a failure, and then a success, right? We want 3 failures and then a success on the 4th trial. So the first try, fail. Second try, fail. Third try, fail. 4th try, success. Then we stop. Now, the probability of failure on the first trial is Q times probability of failure on the second trial is Q. Probability on the third trial is Q times the probability of the success on the 4th trial. Well, that's going to be a P. So what we've got here is Q cubed times P. Or, if you like, maybe P times Q cubed. Now, in general, what if we have n trials, right? We don't know what trial number it's on. Suppose I just want the first success on the nth trial. Okay, in that case, I would need fail, 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 up to n minus 1, right? I would need fail, 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 dot, 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 fail, and then I finally get a success. So I'd get a fail, 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 dot, 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 fail, and then finally a success. So on trial 1, I get a fail. Trial 2, I get a fail. Trial 3, I get a fail. Now I want, what number goes here? This is going to be, now think this is, what I want is a success on the nth trial. I want a success on trial n. So this would be 1 before that, right? So our probability is going to be, what do we get here? We're going to get a Q, a Q, a Q, dot, 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 a Q, and then a P. So how many of these do we have? Well, we're going to have 1, 2, 3, 4, 5, dot, 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 n minus 1, and then finally an n. So this would be, I've got n minus 1 of those Q. So it's going to be Q to the n minus 1 times P. Or, if you like, P times Q to the n minus 1. Or, if you like, maybe you could write it as P times 1 minus P to the n minus 1. Let's do an example. Here's an example. Suppose that approximately 71% of all current college students claim that the main reason for attending college is to make more money after graduation. Now, suppose you start just asking college graduates the reason they attended college. What is the probability that the first person who says they attended college to make more money is the 4th person you talk to? Let's just write it out. You want the first person to say they attended college for some other reason, the second person attended college for some other reason, the third person attended college for some other reason, and finally the 4th person to say, yeah, I attended college to make more money. So what you want is a failure, a failure, a failure, and a success. Probability of failure? Well, probability of success is 0.71. So the probability of failure is 1 minus 0.71, which is 0.29. So we're going to have a 0.29 times a 0.29 times a 0.29 times a 0.71, or if you like, 0.29 cubed times 0.71, although you could do it directly like this on your calculator, right? Just type all that in, or type in this right here. Now, when I did that on my calculator, I got 0.017311731,619. I'm going to round off to 4 places because that's what I like to do with probabilities. All right, so I'll round it off here. That's a 1, so I'm just going to round it off to this, 0.0173. So what does that mean? You know, if I round it off, you know, that's about what? 1.7%, or, you know, it's about 2%. So that would happen, this event would happen about 2% of the time. Or if you even like this, you could say we have tenths, hundredths, thousands, 10,000s. So suppose that 10,000 of us did this. There's 10,000 of us in class. We all go out and we start asking people, why'd you go to college? How many of us would get the fourth person, exactly the fourth person, saying, yeah, they went to get more money after graduation? So it's going to be what? 173 out of 10,000. So if there's 10,000 of us asking, about 173 would get the fourth person saying they went to college for that reason.